This is the mass of a black hole lab. The objective of the lab is to find the mass of a black hole by using the orbit of a star. We will be utilizing Newton's gravitational force law, F equals g m1 m2 over d squared, where m1 will be the mass of the star and m2 will be the mass of the black hole that we are trying to find. We will also be using the gravitational constant g. The results of the lab was that the net force is equal to 2.84 times 10 to the 27. We split the net force into parallel and perpendicular components with these values as shown here, and we concluded that the mass of the black hole is 2.98 times 10 to the 31 kilogram. We are going to use the position data from the stardata.csv file to find the velocities, and then using the velocities, we'll find the momentum using the momentum formula P equals mv. Afterwards, we will break the momentum into perpendicular and parallel components and use that to find the net force. VPython will evaluate the magnitude of the position squared. We will show all of this using a computational model based on VIDLE. Here are some of the data. The star mass is 1.98 times 10 to the 30 kilogram, and the time step is equal to 86,400 seconds because that is the number of seconds in one day. The black hole position is 0, negative 2 e to the 10th, 0 meters. So as you can see here in my code, I put the system properties, which is the mass of the star, the black hole position, delta t, and I set t equals to 0. Over here, I found the V initial and V final using the data, the position data from the CSV file. And then I set that P initial is equal to the mass of the star times the initial velocity, and that P final is equal to the mass of the star times the velocity final. I found that delta V is equal to V final minus V initial, and that delta P, the change in momentum, is equal to P final minus P initial. I set dp/dt as the change in momentum over the change in time, and I set F net is equal to dp/dt. Afterwards, I found P hat and then d mag P dt, and then I set that dp/dt parallel is equal to d mag P dt times P hat. I set F net parallel is equal to dp/dt parallel, and then to find the perpendicular force, I set the total momentum total change in momentum minus the parallel component, and I set F net perpendicular is equal to dp/dt perpendicular. It might be easier to see if we have some formulas in front of us. So as you can see here, that the net force is equal to dp/dt, and that the F net is equal to the sum of the parallel and perpendicular components of the force net. We set dp/dt is equal to, this is the parallel component, and this is the perpendicular component. As you can see, the perpendicular component has a direction component because the perpendicular component is responsible for the change in direction, while here we have the magnitude because the parallel component of the force is responsible for speeding up and speeding down. So as we go back to our code, we see here I put the arrow scales over here, and then later on, to calculate the mass of the black hole, I found all of the force net and the parallel components, and I solved for the the mass of the black hole right here, and then I printed it right down here with the time, the magnitude of the force net, the magnitude of the parallel component of the net force, and the magnitude of the perpendicular component of the force net. And if I run my code right here, as you can see, the black arrow is in the direction of the velocity or in the motion. The yellow arrow is the perpendicular component that will always point towards the black hole, and the blue arrow is the parallel component. So let's move on to the question. So what does it mean? How is Fnet and dp/dt related? So we said that dp/dt is equal to the force net. However, the difference between the two is that dp/dt is quantitative, meaning that we can calculate dp/dt using the data that we have, while Fnet, we have to set that equal to dp/dt because Fnet is qualitative. Moving on to our next question. Imagine the black hole that we found was removed and a different black hole was placed in the same location. Would it be possible to find like a new mass of the black hole that is different from the mass that we found? And the answer to this is no, because nothing has changed. If we have the same position, same location, that means that we have the same velocities and the same momentum and therefore the same net force. So in conclusion, the mass of the new black hole will be the same as the original one. That is the conclusion of my lab. Thank you very much.